So first let us discuss about the project overview. In the project overview, we will be discussing how we have developed our project. That is, the overall project descriptions will present in the project overview. So the main objective of our skin-based disease prediction system is to predict the disease using the AI and deep learning. So in our project, we have mainly used artificial intelligence and machine learning to train the model, which will predict the disease based on the skin and the symptoms. So we have used a deep learning because we have mainly focused on the skin based disease prediction system. Means in the skin based disease prediction system means CNN model will be more helpful to process the skin images so that it can give the accurate results. So we have developed a web application. In this web application, users will be able to verify what all they are using in this project using the deep learning and artificial intelligence, so that users can upload a skin image, and that skin image is captured using the webcam, or we can upload an image using a file section, or they can enter the symptoms through the checklist box, or they can manually type the symptoms, and they can even give their symptoms as a voice input. The voice input will be converted into the text based input. So after giving the disease, if we click on analyze the image, it will process the data, and it will give the accurate disease and what skin disease is predicted. So the key points we have focused here about the skin image upload. I have uploaded a skin image here. So after uploading the skin image or using the webcam image capture, that is the live camera option we have added, even we can add the image through the webcam. After that, as I already said about the text symptom input, we can also give the input in the form of text and also in the form of voice. So in the existing system, only text, voice and skin disease predictions are separated. So in our project, we have built in a common application, so mainly concentrating on the skin image upload as the main home page, and here multi-language support takes place. Means we can change the languages, that is English to Kannada and Kannada to Hindi, because some people don't understand only the English language. So I have developed again both languages, that is Kannada and Hindi. So after that, the report will be generated in the form of PDF format, so that it will be helpful for the users or the patients to analyze what all they have analyzed in their particular skin based disease prediction system, so that they don't need to predict again and again based on the symptoms. Next slide. Next is all about the implemented modules. So as I have already said you about the project overview, means all the full highlights of our project. So first, now let us discuss one by one which module we have implemented and what kind the flow of the execution of the process takes place, what are all the testing we have took. So first, let us discuss about the implemented modules. In this particular web application, we have used 4 modules, that is user module, skin disease prediction module, symptom analysis and additional features. In the user module, what all the features which are used by the users, such as login and registration. First, the user must register to the application. Based after registering using their username, email and the password, next page will open as the login page. In the login page, they should type the valid username and the valid password. If the valid username and the password is not displayed, it will show an error message, that is user not found or password incorrect. After authentication of the users, next page will be displayed as the main page for the skin disease prediction system. In this, we have implemented the modules such as image upload module, through which the user can upload the skin image through their file sections, or they can capture the live image using the web camera. After clicking the analyze button, we can also enter the images in the form of text and also the voice symptoms, because some people don't understand the images names, means symptoms names and all. They can give their voice input. Through one voice input, it will convert into text. Next is the symptom analysis. Based on what features it will analyze the symptom. Based on means image processing, means in the symptom analysis, if we give an image upload, it will resize the image into the particular feature. After resizing the image, means it will resize the image into particular format. After resizing the image, it will go to the trained data and it will analyze what kind of disease it might be. After analyzing, it will give an output for us. In the same way, in the case of symptom analysis, we'll give the text as an input, in which the text will be analyzed, and after the text is analyzed, it will give us the output. In the same will happen in the case of voice to text input. In this case also, voice to text conversion takes place through the modules which we have implemented in our code. So I have added two additional features, that is language translation. So as I already said, we can translate the language. If I click on the translate button in the output section, it will be visible. So if I click on the translate, it will translate through which language. If I select any one of the language, it will translate to the particular language. So in the down bar, I have implemented a PDF report download. So through that, if I click on download report, the report will be downloaded. In the output section, it will display as the disease name, how much percent of accuracy it is having, what all symptoms you will be having, what all the precautions and the prevention measures I need to take, so that it will help here. So in the additional features, I have already included a library section based on what time, what date the disease was predicted and what accuracy it was there. Next is the model evaluation. I have implemented the model execution here. In the model execution, first user login, as I already said, the user registers or logins into the web application. So after logins, next phase is the upload the skin image. In this, user can upload a skin image. After uploading a skin image, the image uploaded is resized and normalized and prepared for analysis to improve the accuracy. So I have included her CNN prediction model. In the CNN prediction model, the which image I will be uploading, it is passed to the CNN, because I have trained our dataset using this CNN model, so which classifies the accurate skin disease. Next is the result generation. After I have uploaded the skin image, next step will be I will be expecting the output, means what sort of disease I am having, what accuracy it is predicting, what symptoms I am having, and what precautions and preventions I need to take to overcome of this disease. So as I have already said, I have implemented the additional features, so user can translate the output into English, Kannada and Hindi, and they can also download the report as a PDF format, and they save the application in the form of the personal library. So I have a personal library, means what all prediction will be taking place, it will be stored in the personal library. Next is the history. In the personal library, all the history will be managed, including the disease name, how much accuracy it gave, and the user details, who predicted and what date and time it predicted the disease, so that user can use it as a reference. On in this date I was having this kind of disease, and this percent of accuracy it was the disease prediction system was showing. Thank you.
Today I'm presenting on the topic the slide testing framework. So testing framework, this slide explains that use it in our AI based system. So testing is essential to ensure that the system works correctly and produces accurate results and performs efficiently under different conditions. So here we have three major types of testing, that is functional testing. First one is functional testing checks whether the system is working according to its requirements and expected behavior. So it verifies all features like image upload, disease prediction, display of results, and it focuses on input and output correctness. Example, if a user uploads a skin image, the system should correctly process it and show a prediction. Next is model testing. So model testing evaluates the performance of the AI model used in our system. So it checks how accurate the predictions are and uses evaluation metrics such as accuracy, precision, recall, and F-score. Next, test the model using test data sets. So ensuring that model can generalize to new unseen data. Next is performance testing. Performance testing checks how the system behaves under different conditions. It measures a response time, speed, system stability, and tests the system under multiple users, large number of requests, and ensure the system does not crash or slow down. Next is performance evaluation. So here performance evaluation has four categories, that is accuracy, precision, recall and regression metrics. First one is accuracy. So accuracy represents the overall percentage of correct predictions made by the model. So here accuracy is 98.25%. This means that out of all the test cases, the model correctly predict the disease in about 98.25% of cases. Next is precision. Precision measures how many of the disease predicted by the model are actually correct. So high precision values indicate that the model produces very few false disease predictions. For example, when the model predicts a patient has a particular disease, there is a very high chance that the prediction is correct. So here precision is 98.31%. Next is recall. So recall measures the ability of the model to identify all actual cases of a disease. So this shows that model successfully detects most of the actual disease cases and misses very few cases. Here recall has a 98.25%. Next is F1 score. So F1 score is the combined measurement of precision and recall. So it provides a balance between correctly identifying diseases and avoiding incorrect predictions. So here F1 score has 98.28%. So higher F1 score indicates that model maintains a good balance between precision and recall. Next, so under that it has confusion matrix. So confusion matrix shows the detailed classification results for different diseases. So rows represent actual disease classes and columns represent predicted disease classes. The diagonal values represent correct predictions and the off diagonal values represent incorrect predictions. So from the given confusion matrix, so first is fungal infection, that is 95 cases correctly classified with a few misclassifications. Next is allergy. So 97 cases correctly predicted and GERD 96 cases correctly predicted. Next, diabetes 97 cases are correctly predicted. So the high values on the diagonal indicate that the decision tree model is accurately classifying different diseases. Next is regression matrix. So regression matrix are used when the model predicts continuous numerical values rather than categories. So common regression metrics include a mean absolute error. So it measures the average difference between actual and predicted values. Next, mean squared error measures the square difference between actual and predicted values. Next, root mean squared error shows prediction error in the same unit as the output. So for disease classification, classification metrics such as accuracy, precision, recall, and F1 score are more important. So next, model evaluation of metrics of a random forest regressor. So it means it recovery time predictor. So a random forest regressor is a machine learning algorithm that combines multiple decision trees to make predictions, and it is used here to predict the number of days required for recovery. So first is mean absolute error. So here mean absolute error is 1.42 days. So it means when absolute error represents the average difference between the actual recovery time and the predicted recovery time. Next is mean squared error. So mean squared calculates the average square difference between actual and predicted values. So here MSC as 3.15 days square. So the MSC value of 3.15 days square indicates that the model has relatively low prediction errors. And R square score, so measures how well the predicted value matches the actual values. So here 0.885 means the model explains approximately 88.5% of the variation in recovery time. Next, actual and versus predicted plot. So this graph compares actual recovery time and predicted recovery time. So the diagonal represents perfect prediction and points closer to this line indicate accurate predictions, and in the graph most points are nearer to the diagonal line, show that the model predictions are close to the real recovery. So next is skin-based prediction system. So this system allows user to upload an image of an affected skin area. So the uploaded image is processed by the AI model, which analyzes the visual features of the skin and predicts the most likely skin diseases. So image upload or analysis. So the system also provides open webcam feature to capture a skin image directly. And after uploading, the user can click analyze to start the prediction process. So here predicted condition is melanocytic navy. So this is a commonly known as moles. So the AI model identifies the patterns, colors, textures, and appearance of the skin lesion to classify the condition. So the system also provides diagnosis details and prevention methods and precautions such as ABCD rule for monitoring changes in moles. Plus, additional features it includes translation support, which we translate languages in Kannada, Hindi, and English, and PDF report generation, which improve user convenience. And next is prediction library. So here it record management system that saves past diagnosis and predictions. So it helps user view the previous analysis results, including the date, prediction method, and detected disease and confidence level. So that here in the prediction library, it has date. So displays the date on which the prediction was performed. So it helps user track when a particular diagnosis was generated. So in mode, it supports two type of prediction mode, that is image mode and symptom mode. So user uploaded skin images for analysis, and AI model examines features such as color, texture, and patterns to identify skin condition. Next is symptom mode. So user provided symptom to predict the possible disease, and the machine learning model analyzes system patterns to classify disease. The next is predicted disease. So this column displays the disease identify the AI model. So example is melanocytic navy. It is a common type of mole detected through skin image analysis like AIDS and heart attacks. Next, confidence score. So this represents how certain AI model is about its prediction. So melanocytic navy has 98.5% confidence, and symptom based predictions is 96.0%. So a higher confidence score indicates that model found stronger similarity between the input data and the learned data. So next is, so in this slide, the system provides a user-friendly interface where user can upload an image of the affected skin area, and users can either drop and drag an image, selected an image, so from the device, or capture a photo using the webcam. Once image is uploaded, the this analyze image button processes the image through the trained machine learning model. Next, the model analyzes visual skin features and predicts the possible skin conditions based on the learned patterns from the system. Next, the interface is designed to be simple and accessible, enabling quick disease screening and assigning users to obtain preliminary health insight. So this result confirms the successful integration of the front-end interface with the prediction model, allowing real-time skin disease analysis. So here others prediction systems are text-based prediction, voice-based prediction, and model evaluation. So first, text-based prediction means user can manually enter their symptoms through a text interface, and the system analyzes the provided symptoms using the trained machine and the learning model. Next, voice-based. So users can describe their system using voice input. So speech is converted into text and processed by the prediction model. Next is model evaluation. So the platform indicates a dedicated model evaluation section. So performance metrics such as accuracy, precision, recall, F1 score, and confusion metrics are displayed. Thank you.
Good evening, ma'am. I am Sanjana. I am continuing with the system demonstration. I am continuing it here with the system demonstration. So here the system demonstration first starts with the user login. So this is the entry point of the system. So here user login means this is the first block of the system where user can enter the username and the user password. So here system that verifies the credentials using the backend. So here we will look towards the authentication ensures. Here authentication ensures it shows about the data privacy. It also secures the storage of the medical history. So we can here use the session authentication. So this model ensures only about the authorized users can only access and sorry ma'am. To the dashboard by using the central interface. So this what are the options available in this means by uploading an image, capturing an image, voice input can be given, text input also given. So this is the multimodal input system we can use it here. So multimodal database can be used here. So this database act as this control center, allowing the user to interact with the system is the multiple convenient ways to use it here. Next will be the input provided. Here input provided means the data collect, what are the data we are collected here. So here this is the system which collects the user data by types of inputs means we can upload here by the skin image symptoms. Skin image by these are the primary images. So symptoms means we can give here by through the text or the voice. By combining the image and symptoms, it provides about the accuracy of that skin disease. So this also gathers all the necessary inputs data requiring all the intelligent prediction. Next will be the image processing. In image processing, data is clean, the data all the data is cleaned here before sending the image to the AI model. It is the processing here, processing is done. Next what are the operations observed here means we will resize the image. For example, we will take the 224 cross 224, the image can be resized here. We also normalize the pixel values. We are for the accurate AI analysis. Next will be the CNN model, that is the core intelligence. So this CNN model is the brain of the system. Dimensions of the reduction, fully connected layer. This is the classification. Next, the CNN model learns about the huge complex visual patterns in the skin images and classifies with the disease categories. Next will be the prediction and the results. Means output generation. Here is the system which gives the final results. Means output includes the disease name, confidence score, symptoms, cause, and the precautions. It converts all the AI input human readable format. So the system provides not only the predicted diseases but also a detailed medical insights also observed here. Next will be the translate results. That is the NLP model. That is the results are translated here. Users are the NLP means the natural language processing. NLP means the natural language processing. Next, it converts the language into the Kannada or English, Hindi or other languages. It also makes the system usable for the non-English users. These features are improved by the accessibility by breaking the languages barriers. Next will be the download PDF report documentation. User can download the report by report can be contains patient details, disease prediction, confidence level, and the suggestions. It can be shared with the doctors and maintain the records. The system generates a structured medical report for the professional the consultation. Next will be save prediction. In this save prediction, database can be stored here. Finally, data is stored and the stored database can be the user information and might also predict the history of the data. Here we use the MongoDB and the SQLs. So this model enables tracking of the past prediction by the long term of the health monitor. So the overall conclusion of this image is by representing the complete AI pipeline that integrates the user interaction, image processing, deep learning, and the data management to deliver the intelligent healthcare solutions. So next slide will be the project significance. In this project significance, in this project, what means by visiting a hospital, by waiting while at time, doctor's availability also required. So here our model requires solves this problem by providing the instant premiality analysis. It also helping the users to detect the user at the earlier stage. So here we use the CNN, that is the deep learning, to identify the patterns invisible to the human eyes in the early stages. So we used here with the real world impact, like it reduces the disease cases. It also prevents with the complications and also it saves the time and the cost. So the system enables by preventing the healthcare by identifying the diseases before becoming the severe. Next will be the user-friendly interface. User-friendly interface, it mainly focused on the non-technical users by featuring like the uploading an image, clicking a photo, and putting the voice input. Many healthcare apps fail because they are very complex. Also, our model ensures that this is a easy navigation and there are the minimal steps we are included here. Next will be the real world impact. We can use it by the for the elderly people. It also used for the real users and for the students also. It's the our system mainly focus on the usability so that every can access the AI powered healthcare without any technical knowledge. Next will be the multi language support. In India has many multi languages, like language barrier is the major issue in our country. So system uses the NLP based translation, so we can translate the languages into many languages. So it converts the English output into the regional languages like the Kannada, Hindi, etc. Real world impact, like the rural populations can be used. Non-English speakers also used. Uh, for example, we take and farmer can understand results in their local language. So these features make healthcare in inform for the diverse populations can be used here. Next will be the maintenance and the predictions history. Here it shows all the previous predictions in the database. So the database systems can be used here. It enables the data retrieval and the history tracking also seen here. Next will be the it generates the medical report. It automatically generates the PDF medical reports. Like it contains the patient details, disease prediction, confidence score, and the suggestions. It also uses the automated report generation system. Next, for all these cases, we can save our time, and it also reduces the manual effort, and it can also stay shared with the doctors. Next, next slide. Next slide will be the challenges and the limitations. So in these challenges, every AI sees challenges. So some of the challenges are the data set collection, similar disease images, and voice recognition errors. In dataset collection, so AI model requires a large, high quality label datasets. So in the medical domain, data is sensitive and private. It requires an doctor annotation, means it requires a doctor consultation. Next will be the similar disease images. So many skin diseases look very similar visually. Acne and the eczema are the examples we took here. Next will be the voice recognition errors. Voice recognition here, voice input uses the speech to text technology. Next will be the image limitations. In these limitations, not a replaceable for in this limitation we will look forward towards the it is not replacement for the doctors. So system provides the only the prediction, not the final diagnosis. So here our system lacks with the clinical examination, lab test, and the patient history. So it must be support the tool, that is the CNN model. So it depends only on the image quality, means accuracy depends on the image quality. If the image is blur, low light, or the incorrect image, it will shows the poor conditions. Next will be the internet dependency, means some of the features requires internet for the translation and the cloud processing. It cannot function fully if the network is offline. Thank you, ma'am. Next slide continued by Sahana.
Ma'am, myself Sahana. I'm continuing about future enhancement. The current AI-based skin diseases prediction system is designed to assign user is identifying common skin diseases using artificial intelligence. All through the system provides accurate predictions and successful health information. This is significant scope for improvement. Future enhancement can make the applications more intelligent, reliable, and beneficial for both patient and healthcare professional. Here, next, mobile application. Mobile application means one of the major future improvement is the development of a dedicated mobile application. Since smartphones are widely used, a mobile app would allow user to access the system anytime and anywhere. The mobile applications can provide real-time skin diseases detection using the phone camera, instant report generation and sharing, push notifications for medication remedies, easy access to previous prediction records, better user experience through a optimized mobile interface. This enhancement will increase accessibility, especially for user living in remote areas where medical faculties may be limited. Next is inclusion of more skin diseases. Currently, currently the system may be trained on limited number of skin diseases categories. Future version can be enhanced by collecting large data and training more advanced deep learning model. Here, additional diseases that can be indicated: melanoma, axin, fungal infection, skin cancer type. Increasing the number of supported diseases will improve the usefulness and effectiveness of the system in real world healthcare application. Next is online doctor consultation. After obtaining a prediction result, user may require professional medical advice. Integrating doctor consulting service can bridge the gap between AI prediction and medical treatment. Futures may include video consultant, dermatologists, live chat supports, appointment booking, electronic prescriptions, follow-up tracking. This feature will help user receive expect guidance without visiting a hospital physically, saving the time and effort. Next is intelligent medicine recommendation. Future version can provide personalized medicine recommendations based on diseases prediction result and sympathize analysis. The system may suggest commonly used medications, explain doses, instructions, display side effects and precautions, recommend skin care product, provide treatment guidelines. However, medicine recommendations should always be valid by certified medical professionals before use. Next is cloud-based data storage. Wood integration can surely store user reports and prediction histories. Advantages: access report from any devices, secure backup of medicine record, improved data management, easily sharing with doctors. Next is variable devices integration. Future system can contact with smart health devices and variables. Its examples are smartwatch, health monitoring bands, fitness tracking. This can help monitoring skin health and overall wellness continuously. Next slide. Conclusion. It means AI-based skin diseases prediction system successfully demonstrate how artificial intelligence and machine learning can be applied in the healthcare sector to assign in early diagnosis, detection, and awareness. Uh, Project assignment. The primary object of this develop an intelligent system capable of predicting skin diseases for user inputs. The system achieves the object by utilizing image processing, machine learning algorithms, and user-friendly interface. It develops solutions are detect skin diseases quickly, obtain preliminary medicine information, understand, sympathize, and predictions, seek timely medical consultant. Here, image upload. User can upload skin image directly from the devices. Real-time image capture allows immediate diseases detection. User can enter symptoms manually if image are unavailable. Voice recognize improves accessible for and disable user. This flexible makes the system suitable for a wide range of user. Um, its prediction output includes disease name, coincidence score, accuracy percentage, disease descriptions, possible causes. This helps gain better understanding of their skin condition. Thank you.
completed, right?
Yes, ma'am.
Okay, I have some question for you. May I ask now?
Yeah, ma'am.
Okay, please come to second slide. Okay, compared to existing system, your project new features, what are the new features added here?
Ma'am, language translation I have added, ma'am, because language translation is not available in the current system. Only in one particular language, that is English language, it is available. So I have added two more languages which will be helpful for the rural people to predict their disease. Otherwise, the system is only specific to the modern English people who understand the English languages. So I have added the additional features such as Kannada and Hindi languages, so that even the rural people, village people, they can also use our system. This is one of the feature which I have implemented comparing to the existing model. And next which I have implemented is the PDF representation model. So in the place of the in the case of the PDF representation model, so they can download the PDF because PDF is not PDF downloading option is not available in the existing model. Only they would predict the disease, and separate models are present for all these three things, that is image, skin and voice input. So I have combined both, and main window I have mainly concentrated about the image upload session, ma'am.
Okay, PDF report download here features is there, but yeah, how many file formats are supported here in this in your project?
Ma'am, can you repeat the question, ma'am?
How many file formats? Different file formats are there, right? PDF, JPG,
Ma'am,
then
PDF will be
image files
supported,
are
ma'am,
there.
because I have included only PDF report download, ma'am. All the features will be placed one by one in the layout format and the proper session format, and through
Uh,
PDF, it will be automatically downloaded through PDF only, ma'am.
okay. Please come to the next testing slide. Testing slide. Uh, what is the difference between functional model performance testing?
Ma'am, functional testing means it includes main functions testing, ma'am. So, like I have already said, which
Tanvi,
of
uh, please answer to this question. Other one.
Function testing describes what system does and the tasks it performs. So it focuses on what system operation and user functions. So next model means it describes what we are using model, that is AI or ML, that is capabilities and improvements used inside our system. Next, performance means how efficiently and effectively the system works, and speed, reliability and scalability and resource usage.
Hmm. How it will helpful to user your project?
yes, ma'am, you're audible, ma'am.
Uh, how
So
it will helpful to user?
user can enter symptoms and medical details. So system process that input data and predict the possible disease.
Uh,
And
suppose I don't know the how I interact with your system, then what I will do?
what I will do?
Ma'am, it is the basic system, ma'am. Everyone can interact, ma'am. We have built a simple interface, ma'am, so that everybody can use it. It is a user-friendly interface, ma'am. We have not implemented any complexity, ma'am, so that everyone can use it, ma'am. There will be no difficulty in using the system.
Uh, okay. Um, can you tell me the individual contributions of your project? Individual
Ma'am, I have
contributions.
implemented
One
the
by one, tell me one by one.
Ma'am, I have implemented all the user interface modules and all the modules based on the system which are required through it, ma'am. And I have implemented all the user interface module and overall the system testing and all I have did.
Next one.
Ma'am, I have implemented the confusion matrix. So, what type of image have a highest accuracy, and the translation languages like Hindi, Kannada, or English.
Okay, you have used an NLP model, right? To translate the one language to another language, right?
Yes, ma'am.
Okay, next one.
Future enhancement. Mobile application, more skin diseases, doctor consultations. These are I implemented.
What are the challenges you have faced during to develop your project, developing your project? What are the challenges faced?
Dataset collection, ma'am, was the major challenge, ma'am, because we were not getting the accurate data set for all the three concepts, that is text, skin, and voice input, ma'am. So we have searched a lot of data sets from the kaggle.com, ma'am, which is one of the major challenge we have faced, ma'am. And we need to find the similar diseases, ma'am, for skin image disease to train the model to get the accurate result. And the skin images were not similar to all the concepts, and one skin disease were varying from another skin disease, so which was another challenge, key challenges which we have faced in our project. These were only the major two challenges we have faced in developing our project, that is majorly on the dataset collection process.
Okay, how you solved that one?
Yeah, ma'am, I have solved that one and I have collected the accurate data set, ma'am. So it is giving the accurate predictions.
Where you collected?
Ma'am, from the kaggle.com, ma'am, I have collected the data sets, ma'am, of all the three systems.
Okay. Remaining next one is there, right? Remaining one person is there, right?
Yes,
She
ma'am.
left the meeting, ma'am.
What?
She left the meeting, I guess,
Sorry.
ma'am, because it is not her name is not displaying here, ma'am.
Okay. Okay, what will do?
Ma'am, wait a second, ma'am. I'll contact her and let you know, ma'am.
Okay.
We can Karen the one with them.
Question is good. Okay, we will wind up this meeting. Thank you, one and all.
Thank you, ma'am.
Sorry, ma'am,
Thank
by
you, ma'am.
network issue it was disconnected, ma'am.
Okay, no problem.
Thank you, ma'am.